After posting my previous videos about hand-grain cutting boards with CNC V-carved inlays, I got a couple of requests for a tutorial about how to do those inlays with the detail about toolpaths, bits, etc, etc. So here it is. My CNC is an Aureux 3X made by a company called Aureux. It's a 1 meter by 1 meter CNC with a 1000 watts spindle, which is pretty similar to an X-Carve or a Shapeoko. For this project I'll use a scrap piece of oak and a scrap piece of paddock, which contrast nicely with the oak. We often hear about the CAD/CAM terms. CAD means computer-aided design. It's all about design, as it says. And the CAM is about the manufacturing. We're going to concentrate on the manufacturing side of things today with the VCarve software made by a company called Vectric. We're not going to look too much into the design. We're going to make something very simple, but this tutorial is mostly about the CAM side of things. So what is this VCarving business all about? Well, we have a base piece. In this base piece, we're going to cut a pocket, which is a female part of the design. In this pocket, we're going to come to insert a plug or a male part, which it needs to fit as exactly as possible within the pocket. And the whole difficulty of the thing is this as exactly as possible. Then we're going to cut out everything that's on top of it, just that make everything flush, and we call it V-carve because it is carved with a V-bit, and the sides of the pocket and the plug are at an angle. You might be wondering, why worry about making this at an angle? Why not just cut straight pockets? Well, there are several problems with that. The first one is that cutting straight pockets and having a fit which is tight enough and not having gaps around your piece would be very difficult, especially with hobby CNCs like my Aureux or X-Carve or Shapeoko. The second problem is that if you make it tight enough, it would be very, very difficult to plug it in if you make a deep inlay. Because we try to make deep inlays so cutting boards are strong enough. They can withstand all the abuse they're going to get when they are used. So all of this is okay if you make very shallow inserts, but straight inserts will not work very well if you make a deep insert, and then the glue will not be able to get out, etc, etc. But there's another problem with that. This problem is the corners. So you cannot cut tighter corners than the radius of your bit with straight bits. It's not possible to make a nice square on the corner. You have to make a radius. If you use a V-bit, as the V-bit is going to get slowly out of the material when it gets to a corner, you are able to get sharp corner and very thin lines. That's the second reason why we make V-carved inlay and not straight carved inlay. All the difficulty with V-carved inlay are about depth. There are a lot of different types of depths in a V-carve, and we're going to look into the main ones. So if I'm looking at my pocket, so that's my female side of my inlay, what types of depths do we have in there? Well, of course, obviously we have the depth of the pocket itself, and that's about it for that part, basically. Then you have the plug which comes into it, and the plug has its own depth, which might not be the same. And of course you need to leave a little bit of space at the bottom so that you can have a glue in there. I found out that about 1 millimeter works quite well for me. We also have to leave a little bit of clearance at the top so that we can come and cut away everything that's sticking out after the glue up. And we can do this either with a bandsaw or we can do it with the CNC. Today we're going to do it with the CNC because I don't have a bandsaw anyway. So Of course, the result of all of this is how much contact we have between the two pieces, and this is of course what's going to make it stronger. That's why we make deep inlays. Here are the values that I use in the videos you've seen, the other videos of cutting boards you've seen. I use 8 millimeters for the pocket depth, 7 millimeters of contact with the plug, and 2 millimeters of clearance gives me a 9 millimeter of depth for my plug, and gives me enough space to cut anything that's sticking out quite easily, you will see, and the glue space at the bottom is 1 millimeter. So with the scraps at my disposal, I have a piece of oak of 140 by 125 millimeters and a piece of paddock of 95 by 70 millimeters. Of course, I cannot make anything bigger than that, so I will make a YouTube button, why not, of a little bit less than 95 by 70 in paddock to inlay it in the oak. So in VCarve, we're going to create a new design, and we're going to give it the dimensions of the base, because we're going to make the pocket first, so it's going to be the oak piece. And it's 140 by 125 millimeters. One important thing is to decide where you want to put your center, your 0 point. You can put either in the center of the piece, or you can put at one of the corners. I generally prefer to put it in the center of the piece, except if you know that in your design you might be engraving there, which means that whenever you change bits in between engravings, it means that it might be difficult if the first bit has carved at that place to find back the Z0 of your new bit. So I generally use the center if I know that I'm not going to carve there. If not, then I use one of the corners. I'm going to import an SVG of the YouTube logo that I found on the internet. It's a Creative Commons, so probably no copyright there, I hope. And I'm going to place it in the center using the F9 key. Just to make things easier, I will group all the vectors so I can resize them and move them around all together. So how big can I make it? Because my paddock is smaller than my oak, and so I don't know exactly, because the dimension of my piece here, the dimension of my piece of oak. So what I'm going to do, I'm going to draw a rectangle of exactly the dimension of my piece of paddock, which is 95 by 75 millimeters, and I'm going to center it in the design using F9. This way, I'm not going to use that one for carving at the moment, but I know exactly how big I can make my YouTube logo, and will have enough space on my paddock piece to carve it when I make my plug, and I center it with F9 as well. We're going to carve everything around the triangle, but we see that we're not going to carve the triangle in the pocket, so no problem, I will not carve where my 0 is, so I can leave my 0 point in the center. We are now done with the very simple CAD design part of the project. Let's jump into the manufacturing CAM part, which is the interesting part for this tutorial. Okay, so let's get into Toolpath. I generally stick that window up there because I hate when it closes itself all the time. Don't know if it's the same for you, but I prefer to pin it up there. So I will select my logo, all of it, and I will make a VCarve toolpath. So you remember, we don't make a pocket toolpath, that would be a straight toolpath as we saw earlier. Now we're going to make a VCarve toolpath. So one of the most difficult things to understand with Vectric VCarve, I think, is the cutting depths, the start depths and the flat depths. So let me dig a little bit deeper and explain what those two mean. So if you have your machine bed, which is your waste board on your machine, then you will put a piece on top of that. And your reference, generally your 0 reference for the depths would be what they call the Z0 in VCarve, which is the top, the flat top of your piece. Below that you have the start depth. So if you want to carve into a piece that's already been carved, you can tell VCarve to start at a given depth. That's the start depth. One thing important to understand is that VCarve will assume that everything between the Z0 and the start depth is already empty, has already been carved. That's going to be very important for the following carvings that we're going to make. So what you need to be carved, what you want to carve at the bottom, what we'll actually carve is between the start depth and the flat depth. The flat depth is the bottom of your carve. So if you look at the blueprint of what we want to carve, we're going to look first at the pocket. The pocket needs to be 8 mm deep. So that's a pretty easy one. The start depth would be 0 mm and the flat depth will be 8 mm. Quite straightforward there. We're just now going to create the toolpath with a start depth of 0 mm and a flat depth of 8 mm, quite easy. I'm going to use a 15-degree V-bit, and we're going to see why I use a 15-degree V-bit later. And this is what I have in my bits toolbox. And of course, the parameters will differ depending on your bit and your machine. You need to adapt those parameters. So why 15-degree V-bit and not 16-degree or 90-degree? Well, the explanation is quite simple. It all depends on how deep you want to go with your carve and the thin lines you want to make. If you want to cut a thin line like that and you have a 90 or a 60-degree V-bit, then you're not going to be able to carve very deep, because the angle of your bit will limit you in the depth. If you go too deep, you will go much wider than what you actually want to carve. If you want to carve the same width, but with a much, I would say, more pointy bit, like a 15 degrees or a 10-degree bit, then you're going to be able to carve much deeper, which means that your inlay will be much stronger, even though from the outside the result will look the same. So the one done with the 15-degree will go much deeper in the pocket. So let me put the right feed and speed for my machine. Then again, it will differ, of course, depending on your spindle, your bit, and your machine. So I use a feed rate of 1000 millimeters per minute. Works well with my machine, and I can do pass depths of 4 to 5 millimeters without any problem. We do have quite a bit of material here to remove around the triangle, so we're going to use a clearance tool, and I'm going to use a 3.175 millimeter clearance straight bit, which is 1/8 of an inch. You can select the width of your clearance bit depending on how much material you want to remove and how thin the lines. If you're carving characters, for example, you might want to select 2 millimeters bit for clear out. If you want that bit to be able to go into the characters, and you don't want the V bit to do too much of the clearance, the clear out of the wood, because then it takes a lot of time to do that. So I'm using a 3.175 millimeter, 1/8 of an inch straight bit for the clearance tool. For the rest, we'll keep the standard parameters. You could decide to make what they call a raster toolpath. What a raster does is that it does a kind of a horizontal or vertical straight lines toolpath, which is very nice when you want to clear out things. We're going to do that when we want to remove everything that's sticking out of the plug while once the gluing is done. But for now, we're going to stick with an offset normal toolpath, and we're going to save it. This is how it looks like. Let me just quickly show you how a raster toolpath would look like to compare. So this one goes around all of the objects. This is what a raster toolpath would look like. We would do straight lines going from left to right, up to down. But we don't use that because the finishing is not as good. It's good when you want to remove a lot of material, and that's what we're going to use later. So let's remake a normal toolpath, an offset toolpath, and save it. So let's simulate it to see how it looks like. Seems nice. We can also look at the two toolpaths separately. First, the clearing toolpath with the 1/8 of an inch bit, 3.175 millimeter straight bit, and then the finishing toolpath with the 15-degree V bit, which is going to put those nice slopes, which is going to give us a nice tight fit when we're going to put the pieces together. Looking good. So let's save our toolpaths. The post processor you use might differ depending on your machine. This one, the GRBL, works well for the Arduino based GRBL machines, but could depend if you use another machine. You could use another processor, of course. So we save it under his name, a good name, and then I'm going to save that pocket part. I call it pocket, which is a good name for her. And I'm going to save it also as a plug part. So now I'm going to start working on the plug. I always start from the pocket to create the plug. I'm going to delete all of the existing toolpaths which were for the pocket, because now I'm working on the plug. If you remember, we had created that rectangle exactly at the size of the piece of paddock that we're going to use for the plug. So we're going to change the overall dimension of the material to the size of the paddock piece, which is 95 by 75, and the thickness is 17.5 millimeters, which I measured earlier. This is important because we're going to cut through the whole material at some point, so you need to know what the exact thickness of the material is. You have to visualize that we're cutting the plug here. So it means that we are cutting inside of the triangle and outside of the small, like television shaped square there, which means that I will carve where my zero is. So it's going to give me a problem when I want to put my zero depth for my second bit in the carving, because the material will be gone there. So I'm going to move my 0 point for that one to the bottom left corner of the piece. It's going to be easier for me when I change my bits. I explained that in the beginning of the video. We can remove the rectangle that we had made first to avoid making our logo larger than the piece we had for the plug. It's not needed anymore. And now we're going to create the toolpath for the plug. One important point to remember at that stage is that you are cutting a plug which is supposed to insert into the pocket. So let's imagine that you have carved that shape in the pocket. It would look like that if you cut through it. And let's say that we make the same piece but in negative for the plug. What's going to happen when you try to put them together? Yes, of course. So you need to remember that you have to make a mirror of the image to make your plug. If not, and believe me, I've been there, you're going to go for a disappointment when everything is done and you want to glue things together. Mirroring a piece in VCarve is pretty easy. You select it and you have a special mirror button up there, and you can select to mirror it vertically or horizontally. Both work for your plug. You will just have to flip it on one side or the other when you're going to insert it into the pocket. In this case, as my piece is completely symmetrical on an horizontal axis, if I do a flip vertically, you see no difference. Actually, I don't really need to make a mirror before I do my pocket, but if your piece is not symmetrical, then of course you need to mirror it, especially if you're doing, for example, you're engraving text, very important. Do a mirror, preferably an horizontal mirror, before you cut the plug, or else it will not fit into the pocket. Now if I select my logo and I ask VCarve to make a VCarve toolpath, what will happen is that it will make exactly the same toolpath that it did for the pocket, because it's the same parameters and the same design, so there's no reason why it should be different. So we have to make it understand that actually it has to make a negative of that. And how do we do that? We just enclose the design into another vector. So I will remove this toolpath and I will ungroup my design, so I can select only the outside vector, not the triangle. And I will select that outside vector and I will create an offset vector. It means it will design another vector, and I will ask VCarve to make that other vector outside of the one I selected, outwards, and at a distance of 10 millimeters or 8 millimeters in that case. Not very important at the moment. You don't delete the original, of course, you want to keep the existing one. So now we have an offset vector 8 mm outside of the logo. It's a little bit larger than the piece that we have designed, but that's okay because we have a bit of spare around the real life piece. So if we now select everything and we ask VCarve to create a VCarve toolpath with that, it will be the negative of the one we had before. So this is where things get a little bit hairy and that people have sometimes problem with VCarve. I had some problems. I had to experiment a lot to understand everything was going on there. It was pretty easy for the pocket. We had 8 mm depth, and so we had a start depth of 0 and a flat depth of 8 mm. But it's a little bit more complicated for the plug. This is what the plug looks like in the complete, I would say, blueprint of our design, of our carving. Let's isolate it. So we want the plug to fit into the pocket by 7 mm, and we want to have 2 mm sticking out of the pocket. So let's turn things around by 180 degrees because that's how it's going to be installed on the machine. As far as VCarve is concerned, the Z0 is the top of the piece. Then the 7 mm are the start depths for VCarve. So you have a 7 mm start depth from the Z0. That's the contact of the two pieces. That's how they plug into each other. And then you have 2 mm sticking out of the pocket. That's the flat depth for VCarve. So the piece fit together, the contact 8 is 7 mm, and then you have 2 mm sticking out. So the parameters would be, for the pocket, 0 mm start depth, 8 mm flat depth. Pretty easy, that's the depth of the pocket. For the plug, we have a 7 mm start depth, that's the depth of insertion of the plug into the pocket, and 2 mm flat depth, which is what's sticking out when it's been inserted into the pocket and that you're going to have to clear out later. For the example here, I'm going to assume that I make 2 mm passes. So for my pocket, if I have to start at 0 and finish at 8, start at 0, flat depth 8, it's going to make 4 passes of 2 mm. Pretty easy there. But now let's take a look at the plug. We have a start depth of 7 mm, and remember that the start depth is supposed to be a place that is already carved when you start this specific toolpath. So if I look at my plug and I say I have a start depth of 7 mm, what VCarve is going to assume is that everything above those 7 mm is supposed to be already empty, but it's not the case because we have not carved anything yet. We're just using that because it's the way to tell VCarve that that's the depth at which we want the plug to insert into the pocket. And so it's going to generate just one single pass of 2 mm. But in reality, what's going to happen is going to plunge directly at 9 mm in total and carve 9 mm, which is way too much for our hobby CNCs like Shapeoko, Aureux or VCarve. And you're going to break something, or you're going to have to go very, very slowly to do that. So we have to find a way to go around that and avoid that VCarve directly plunges at 9 mm in that case, as I explained, because of that start depth which it thinks is already cleared out. So we're going to actually trick VPart by creating manually additional toolpaths. In this case, for the example, I'm going to create 2 additional toolpaths. A first one which starts at 1.5 and goes to 2 mm, so a total of 3.5. And a second one which starts at 4.5 with a flat depth of 2 mm, so it's going to take an additional 3 mm from the first one. And this is something that we use to trick VCarve into just then after that it's going to make the last one, which is the 7 mm start depth, 2 mm flat depth, which is going to be after the 2 other ones an additional 2.5 mm, and we have our 9 mm of carving without breaking anything, the machine or the bit. So let's generate the first toolpath, where you remember we said we have a start depth of 7 mm and a flat depth of 2 mm. We use the same bits as we used for the pocket, and we will call it the plug toolpath and save it. If I now reset the toolpath preview so I can see what it looks like, you see that it will actually carve what we want, which is the negative of the pocket that we have carved before to make a plug. So the clear out and the finishing pass with the 15-degree V-bit. But as you see, it's going to go pretty deep, 9 mm in one pass. So we're going to have to create those additional toolpaths that we just described in the video. So we're going to create additional toolpaths, VCarve toolpaths. The first one will have a start depth of 1.5 mm and a flat depth of 2 mm, so total 3.5 mm. I'm going to call it plug pass 1. And the second one with a start depth of 4.5, a flat depth of 2, which is an additional 3 mm compared to the previous one, which I'm going to call plug pass 2. So let's reset the preview and see how it looks like. We will hide the toolpath, reset the whole preview and start the first toolpath. It looks correct, except that it actually goes directly to 9 mm because it will make the toolpaths into orders they are shown here. So we must change the order of the toolpath now so that we make sure that we start with the shallow ones. So everything which is marked clear 1 is my 3.175 mm 1/8 of an inch bit, which needs to run first, but we need to first run the first pass, then the second pass, and then the final pass. So we do the same for the 15-degree V-bit passes, and we reorder them in pass 1, pass 2, and then final pass. Now let's make a full preview again. Toolpath after toolpath. First one goes down to 3.5 mm. Second one with the clearing tool will go another 3 mm, so 6.5 mm, and the last one we go to 9 mm. This is exactly what we want. Same thing for the 15-degree V-bit. First pass, second pass, and the final pass. So we don't remove too much material at once. We should be okay and we will not break anything. And this is how you create those pre-passes, so you avoid that your bit goes too deep if you go directly to 9 mm. So now we must isolate that plug from the rest of the material. So one of the ways to do that is to cut around it with a bandsaw or a hacksaw, but we have a CNC and the piece is already on the CNC, so why not take advantage of it and isolate the plug using the CNC itself. So let's make a toolpath for that as well. So by using the vector that we have created, the offset vector, to cut around the toolpath, we will reuse that vector to create another toolpath to isolate the plug. This is going to be a profile toolpath, and it will go to a depth of 17.5 mm, which is the thickness of my material. So I will cut completely through the material. But of course you should not cut through the material and isolate completely the plug if it's not attached either to the wasteboard or to the rest of the material. So we're going to create tabs. So tabs are small pieces that you leave. You do not cut completely through the material in the tabs, so it stays attached to the rest of the material. Let's create 4 tabs here. Actually my piece is much larger than that, so it's okay. My tabs will stay attached, and the tabs will be 3 mm in length and 3 mm in thickness. So let's see how this looks like. We're going to cut inside of the vector, and that's important. Let me explain why. If you remember, there are 8 mm between our logo and that vector, which means that we have more than enough space to go in there with a 3.175 mm bit or even thicker and completely cut through the material. We don't have to worry about touching the piece, but also it is already in there, it's already carved until down to 9 millimeters, so we don't have to recarve that. So just to make sure that I have a bit which is long enough, I'm going to use a 6 millimeter bit, which is longer than my 3.175, and I have space for that anyway because I have 8 millimeters. And as I know that I've already carved in there until 9 millimeters, I will tell VCarve to start cutting at 9 millimeters. Let me show how I do that. So let's first calculate the toolpath so you can see it. So as you can see here, we're going to cut inside of those lines. So we can start lower, we can start at 9 millimeters. So we tell VCarve to start this cut at 9 millimeters. We do that by setting a start depth of 9 millimeters. We're going to cut inside of the line, so we will be in the place in the material that's already been carved, and we're going to go down to 17.5. So we start at 9 millimeters, and from there we cut another 8.5, and the total will be 17.5 millimeters. So I will calculate it again now, and there we go. I have a cutout which starts at 9 millimeters and finishes 8.5 millimeter down, and this is how it looks like when it's done. You can see the tabs there, which are going to let the plug keep the plug attached to the rest of the material. So that way I don't have to use a bandsaw, which I don't have anyway, to isolate my plug. It will be much easier and faster for me. So we end up with quite a good number of toolpaths there, and we're going to have to save all of them and run all of them one after the other. Between each toolpath we have to reset, even if it's the same bit, reset the Z0 of the bit, etc, etc. So we'll take advantage of a small features of VCarve which is very, very useful in that case. It's the ability to group toolpaths together. So I'm going to select all the 3 toolpaths that run first, and all the 3 of them use the same bit. It's the 3.175 millimeters, the 1/8 of an inch bit. So let's select the 3 of them. And when we want to save them, as they use the same bit, we can use the option output all visible toolpaths to one file. It means that VCarve is going to put all of the toolpaths in the same G-code file, and they're going to run one after the other without stopping. So you don't have to reset the Z0 of the bit, restart the machine, load the toolpaths, restart the machine, etc, etc. So you gain quite a lot of time by doing that. So I just save them, I call them plug 3.175 because it's the size of my bit. I generally use the size of my bit in the name of the toolpath, so I don't make stupid mistakes. And then I do the same for the 3 toolpaths that use the 15-degree V-bit. And then I will save the toolpath that does the cutout, and I will save it on its own, and then it uses a 6 millimeter straight bit. So I select it. I need to select it to save it, and then I call it cutout 6 millimeters. And then I have all of my toolpaths ready for the plug, and we will be able to head to the machine. You probably remember that for the pocket we put the 0 point at the center of the workpiece. I use a 1/10 of a millimeter gauge to put the Z of my bit without touching my workpiece, and now we can start digging. As I'm going to cut through the material to isolate the plug, I'm going to install a sacrificial 6mm MDF board on the bed of my machine to protect my my waste board. As you can see, I've already cut quite a lot of things on that one. It's very cheap and it avoids that you damage the waste board of the machine, which is much more expensive. The next day, when everything is dry, I will remove the clamps and I will measure where is the highest part of my plug and how high it is. It is about 9.7mm at max, and I will mark on the piece the highest point, and I will use that to create my cleanup toolpath. So I will start from my design of my plug. I will ungroup it so I can select only the outside vector, and as before I will create an offset vector outwards of this one at 10mm, just to make sure that I remove everything. And then we need to, before we create the toolpath, we need to actually put a depth in there, but we want to make absolutely sure that we do not touch the wood. So I use that little trick. Using that gauge, I will put my bit 0.5mm above the surface. And this is, I don't want to go deeper than that, so I'm sure I do not touch the wood of the base. And I will tell my CNC to go up 10mm. I know I have to carve 9.75, but that's a little bit too much, but that's okay. So I move up 10mm and I will use that I my 0. I know that from there I will go down 10mm and I will finish 0.5mm above the surface. So let's create the toolpath. We're going to select the right vector, then create a pocket toolpath, and it's going to be 10mm. So if it's 10mm, it will go down 10mm and go back to the 0.5mm above the surface. So I'm safe with the surface here. I'm going to put a pass depth of 5mm and slow down a little bit the feed rate, so I only have 2 passes because I need to remove 10mm, so I prefer to have a 5mm pass depth and only 2 passes. Even if I go slower, it will be faster. I put a low plunge rate because it's a big bit, it's a wide bit, and I'm going to use a climb vector. It's to clear out material. You remember, it's the one making those left and right or up and down straight passes. I call it clear 6mm, but I see it goes upwards or vertically. I would do less changes of a direction if I was going horizontally, so I will change the raster angle to 0 degrees, so I make horizontal passes, and I will make less changes of direction. It will be a little bit faster. And this is one of my favorite moments, when you finally see the final result appear. Not completely final, but at least you get a good idea that things went right. We're almost there. Now we need to make quite a bit of sanding, starting with 40 grit up to 180 to 240 until everything is gone, including all of the glue that is on the wood. As it's not a cutting board and it's not touching food, I can use a non-food safe finish, so I will use clear varnish here to finish my small YouTube button. I will put like 2, 3, 4 coats of it. And here is the final result of that simple project. So a very simple one, but it shows you all the steps and how to create all the toolpaths for a good deep V-carving using Vectric VCarve. I hope it was useful for you that I did this tutorial, that you will share with me your creations. I'm very interested to see them, and I hope that you enjoyed that video.